Hello and welcome back for our last mini lecture in Chapter 5. In this mini lecture we will be discussing section 5.3 in your book, which is astronomical images and detectors. And we're just going to sort of skim through some main topics. In the past we would have spent quite a while on this, but now that you have digital cameras on your phones, most people actually, whether they know it or not, already understand how astronomical imaging works. So a telescope is just a collector of light. It's a funnel, and it'll collect a large amount of light, but it has to send the light somewhere. If you didn't have a camera at the end of your telescope, it would just pour out on the ground, and that'd be wasted, and who wants to waste photons from deep space? So in order to collect the light from telescope, astronomers use very high-end digital cameras. These digital cameras are very similar to the cameras that are in smartphones, and they're even more similar to high-end digital SLRs and so forth. So these digital detectors detect the incoming light and then send it to a computer, and we can sit in a place where it's warm and dry and not have to be out in the dark of the telescope dome and fall asleep while we are recording our data. These images are then stored on a computer disk, and we take those images home for later analysis. We don't work on them too much right there at the telescope. Here's a picture of the control room at the Magellan telescopes in Chile. They've done some upgrading since then in that they've replaced all those cathode ray tubes with new LCD screens, but other than that, it's very similar. Each screen is telling you about a different computer controlling a different part of the telescope or the instrument or the camera. And here at about 3 or 4 in the morning, you really don't feel like doing much of anything. The computers are doing all the work, recording your data. You can sit and Facebook, listen to iTunes. Looks like Eva here is doing a little bit of programming, all that kind of fun stuff. The digital cameras that we use are black and white. They record the incoming photons, and they record how many photons of light have come in from each star and each galaxy, but they don't record the color of the photons. So here is a picture that we took at the Magellan telescope, and you can see some stars and galaxies here, but you don't know what color they are. If we want to get colors, we have to put filters in front of our telescope. So we have a couple of ways of doing this. On the left, there's what's called a filter wheel with different astronomical filters, and we can stick one of those filters in front of our CCD camera and take a picture, and then we can switch filters and take another picture and switch them again and take another picture. On the right is sort of a state-of-the-art camera that was built to take pictures of large portions of the sky. This camera, which was built for the Sloan Digital Sky Survey, has several banks of 5 filters, and the telescope moves in such a way that every star and every galaxy will pass over every one of the 5 filters. And so at the very end, the computer is able to piece together a color picture and color information from that. So to get color information, we just measure how bright an object is through each of the different filters. So here's a picture of the planet Mars taken by the Hubble Space Telescope. At the top row are the 3 black and white images taken through filters. On the left, it was taken through a blue filter, center was green, right was red, and you can see that the blue image is fairly dark, whereas the red image is fairly bright, so that should tell you right off it's going to be a reddish color. And we can then assign the colors to each of the filters, and if we want a color image for like a press release, we can get graphic artists to combine them together and make a true color image down at the bottom. So some people think this is cheating, that this isn't a real way of getting colors, but in fact this is the way that every digital camera takes a color picture. Inside your camera there are little colored filters in front of every single individual pixel, and then the camera software combines the individual color pixels together to make an overall color picture. So that's basically all I want to say. Telescope cameras, we use digital cameras to take pictures. We use a device called a charge coupled device, or CCD, to do that. The digital cameras naturally take black and white photos, so to get color, we have to take pictures through different filters, different colors of glass, and combine them. Your camera on your phone does this automatically. We usually do it separately because we can get higher resolution images, sharper images, by doing the filters one at a time. So it takes more time than it would with a single shot, but we get a better image. So this completes the third and final mini lecture for the chapter on telescopes. And so please go and complete the mini lecture response on eCollege.